We
are
the
Sky Knights.
I'm Bradley, I'm 19, and I'm in the Engineering Science Associate Program.
Hi, my name is Elham Adam. I'm 20 years old and I'm part of the Engineering Science program at CT State.
I'm Marcellus, I'm 19, and I'm in the Computer Science program here at CT State.
The reason I wanted to take up this challenge is because I wanted to be part of a dedicated team.
I had wanted to make a drone for a long time before this, so when I saw the posting for a drone challenge, I just hopped on it immediately.
I wanted to join the team because I've always been a part of robotics during high school, and so I wanted to see what goes into making a drone and making a functional drone.
At first, just making a drone was intimidating and satisfying enough for me, but once I understood the process better, my ambitions immediately jumped to making a robust sample collection system, and then fully into the mapping, and then into the surface level of autonomous.
I also wanted to learn about CAD and more about mechanical design.
I wasn't too experienced in Python, so I wanted to learn a little bit more about scripting in Python, and I also wanted to know more of like the mechanical side.
I recently CAD modeled these propeller guards and landing legs, which turned out to be a deep dive into system integration. I had to analyze the impact angles of a potential crash to make sure that the guards were protecting where the propellers were most vulnerable.
For this challenge, I was mostly concerned with weight reduction, video, mapping, and autonomous. To reduce weight, I swapped the F450 frame for a 7-inch carbon fiber frame and went for a 4-in-1 ESC. For photography, mapping, and autonomous, I tried to kill 3 birds with 1 stone using an AI depth camera. The OAK-D software easily creates scaled point clouds, which is also necessary for SLAM. Finally, I wanted a reliable scoop that minimized user technique, so I went for a servo-powered design.
For addressing mapping and autonomous, we wanted something small and powerful. So we went with the 8GB Raspberry Pi 4B to handle the connection to the flight controller and to handle the pipeline for mapping.
Throughout the project, the biggest thing I learned is that things are not going to work out for you on the first try, but the greatest thing is that you learn from those errors, you learn from those mistakes, and in the end, you're going to overcome.
During this project, I learned how to 3D print and model. I also learned about 3D and 2D mapping and the softwares used to create those maps.
I learned a lot about electronics, stuff like how to solder, connect wires, and also a lot more about CAD.
I also leaned on my teammates a lot during this project, especially when it came to learning software such as SolidWorks.
I also was able to get some experience in soldering, putting together different drone parts, and I learned a lot more different things about Python and Raspberry Pi and scripting.
I think the thing I learned the most about was project planning. How to take a vague idea and turn it into something concrete and actionable.
I think the most important thing I learned during this project, though, was the importance of teamwork. There were many people who aided us and advised us, and I think we wouldn't have been able to achieve what we have achieved without them.
I made so many mistakes in these past 4 months, more than engineering undergrads do in like 2 years. So I'm very confident my next drone will be an engineering marvel.